All right, in this rope and pulley problem, we have a cable A, B, and C that has a length of 7.5 feet. We are going to have to determine position X and also the tension in cable ABC required for equilibrium when the cable supports a load of 75 pounds. We are going to assume that the pulley is frictionless and we'll be neglecting the radius. The first thing we're going to do is we're going to draw a free body diagram around the pulley itself. Okay, here I've drawn the free body diagram around point P. You'll notice that I have the 75 pounds going straight down. And you also note that I have the two forces, okay? And here's the trick about pulleys. When you have a pulley, the rope or the tension in that cable, okay, because it's a pulley and it's frictionless, will be the same. So it's the same tension in that line because it is the same rope or pulley or cable. All right, so the next thing I want to do is also try to determine what these are. So let's first look at the summation of the forces in the x direction, okay, and the law of equilibrium states summation of forces in x, because it's static, is 0. All right, so let's break this down into its components. So I would have the positive here, so I'd have T, the tension, times cosine of theta, calling that angle theta, minus, because this is in the negative direction, T cosine, and I'm just going to use alpha, okay, and that's equal to 0. Now let's set these equal to 0, and we get tension cosine of theta is equal to tension cosine of alpha. Well, the t's cancel out, and you're left with cosine of theta equals cosine of alpha. So what we can conclude from this is these angles are the same. Theta is equal to alpha. Next, I'm going to do the summation of the forces in the y direction. In this case, also equal to 0. Now I'm going to put all my components out. So then I've got, these are both going in the positive direction. I got 75 in the negative. So it's going to be, and I'm going to use theta on each side. So tension sine of theta is that component, plus tension sine of theta, okay, minus 75 is equal to 0. All right, so now I'm going to simplify this expression, and I'm going to bring the 75 over. There are two t's, so this just breaks down to 2 sine of theta times t, okay, is equal to 75. Solving for tension, okay, I'm going to get tension is equal to 75 divided by 2 divided by sine of theta. Okay? So now we have tension in terms of theta. All right, now it's a good idea to draw another free body diagram, but more or less we're actually drawing the triangle. So if you notice that the difference in height between A and C is 2. We know the distance, horizontal distance between A and C is 6.5. So now I'm going to draw a couple triangles with that information, and also note that the length of the cable A to B to C is a total length of 7.5. So we're going to use that information, and I'm going to draw two triangles. All right, let's look at some of the information we were able to derive from that. So we know that the distance from horizontal distance here is 6.5 feet. We know the difference in the heights here are 2 feet. So we're breaking them up in these two triangles. Theta is the angle here, okay, still unknown. its complementary angle is this angle here. So that is also theta, and this is theta. The distance between here and here is 2 feet. So we're going to give it another variable here. From here to here, we're going to call that y. Okay? And now we're also going to call, we've been given this the term for x, which is the distance on this side from here to here. And then we can define this side in terms of x also, because the total distance is 6.5 feet. So this works out to 6.5 minus x. Also, the distance from here to here we're defining as L1, and the distance from here to here we're defining as L2. And we were given that L1 plus L2 is equal to 7.5 feet. All right, now we're going to take the cosine of theta for each of these triangles. So the cosine of theta is going to be equal to the adjacent of our hypotenuse. So cosine of theta for this triangle is equal to x divided by L1, and the cosine of theta for this triangle is going to be 6.5 minus x divided by L2. Now what we've done is we've solved L1 and L2 in terms of x and cosine theta. So now we have L1 and L2 in terms of x and cosine theta. Now what we're going to do is we're going to substitute in these values into this formula here. Okay, so then we're going to end up with, so we're going to substitute that in, so we're going to end up with x divided by cosine of theta plus 6.5 minus x divided by cosine of theta is equal to 7.5 feet. All right. Now, what we're going to do here to simplify this is we're going to multiply cosine on either side. Okay. So we're going to end up with x plus 6.5 minus x is equal to 7.5 times cosine of theta. All right. Now, as you can see here, these terms drop out. Okay. And we can solve for cosine of theta and thus derive more of that. So then this is just going to be equal to, so we go cosine theta. Okay. And that would have to go on this side, so it's going to be 6.5 divided by 7.5. Okay, solving for cosine theta, and we get 29 theta. Oops, let me pull this up. Sorry, I can't see that. There we go. We get 29.93 degrees. All right, so now we can use this to come back up here and solve for t. Okay, so taking this number here, plugging into here, and we get t. And so we get, I'll move this up a little bit more. So then I've got t is equal to, my calculator, I get 75.16 pounds. Now the last thing we got to determine is this x here. And there's probably a couple different ways you can do this, but I'm going to use tangent. So what we're going to do is we're going to take tangent of this theta, and we're going to take tangent of that. So if I do tangent, so hopefully I got enough room here, I'll do tangent of this theta, same angle, is y divided by x. And now I'm going to put that in terms of y, solving for y. Y is equal to tangent of theta times x. Okay. Now let's take the tangent of this theta. Okay. So that tangent of theta is equal to, now this is y plus 2 here. Okay. So that is y plus 2 divided by, and remember that's 6.5 minus x. So we're going to make that substitution here, okay? And we're going to put that in, so that is equal to tangent of theta x times x, okay, plus 2 divided by 6.5 minus x, okay? So we know, okay, what theta is, and we know what x is, so we can solve this now, okay, and get that. So I'll just simplify this. I'll multiply this 6.5 minus x times tangent, so I'll get tangent of theta times 6.5 minus x, okay, and that would be equal to the top there, tangent of theta times x, and that is plus 2. So now, taking this and solving, we'll solve for x. And this results in x is equal to 1.513 feet. So again, to recap, the tension in my cable, okay, is 75.16, or if we report it to 3 decimal places or 3 significant digits, 75.2. And x is 1.513 feet, or if we're, again, reporting it to 3 significant digits, is 1.51 feet.